Hello, I'm Scholastic Sam. Welcome back to my YouTube channel. Today in chemistry and stoichiometry, we will be learning about lesson 4.4, mole ratios and mass-to-mass conversions. Now, pretty much, this means we'll be learning how to have a mole as a given and get to a mole as a result, and also have a grams as a given and get to another grams as a result. But in equations where there's a mole ratio that's not 1-to-1. Now let's get into what that means. So we see this balance equation. N2 plus 3H2 goes to 2 NH3. Now, we know that doesn't actually mean 1 molecule of N2, 3 molecules of H2, and 2 molecules of NH3. It's really a ratio. N2 to H2 to NH3 is 1 to 3 to 2. So it can mean 1 molecule of N2 plus 3 molecules of H2 goes to 2 molecules of NH3, but it also means 1 mole of N2 plus 3 moles of H2 go to 2 moles of NH3. Because you can't actually manipulate 1 molecule of anything, it's really, really small. We don't want to have to count all that out. So, hence the reason moles were invented. Because now, what we can do is we can use moles in the equation and make it much easier to calculate all that. So let's get down into our problem. So basically this is our balance equation. So our ratio of NH3 to O2 to N2 to H2O is 4 to 3 to 2 to 6. Now before we've been acting as if it was 1 to 1 to 1 to 1. But if you're converting between different chemicals, you're going to have to know the ratio and the equation. Because this means that there are twice as much NH3 as there is N2, because the ratio between NH3 to N2 is 4 to 2, which is the same as 2 to 1. So given 25 moles of ammonia, how many moles of water can be formed? So we have moles of ammonia. So let's start out with our given. We have 25 mole of, that's ammonia right here, and this is water right here. So of NH3. Let me go or draw my dimensional analysis lines. So we want to convert that to moles of water. So we have moles of NH3, and we want to get moles of water, but the mole ratio is 4 to 6. So it's not going to be the same, it's going to be different. So we have times 6 moles of H2O over 4 moles of NH3. So then these cancel out, and we're left with 6 times 25 is 150. 100. Let's get a decimal. So let's use our calculator here. We have 25 times 6 over 4 is 37.5 equals 37.5 moles H2O. Now, see what we did there was we took our given moles and just converted the moles using the mole ratio. So this literally means for every 2 moles of ammonia, there are 3 moles of water, or 4 to 6, 2 to 3, same thing. So all you have to do is a simple calculation. Now let's do it with mass to mass. Now, the only knowledge taking you from what you previously knew to the mass to mass conversion is the mole ratio. So now let's look at this. We're dealing with ammonia and water again, so let's underline those there. And we have to underline our given. Given 21 grams of ammonia, how many grams of water? But let's get rid of this thing right here, because that's actually wrong. So So we have to, there. Sorry about this, guys. So first what we have to do is, this seems like a long thing to do. So we have to plan it out. So we're given grams of ammonia. So we know we have to get grams of water, but we can't just go right there. We have to do our mole ratio. So we have to convert to moles of ammonia, do our mole ratio, and convert back to grams of water. So let's start off by writing our given. We have 21.2 grams of NH3. Now that we have to convert to moles. So NH3, N is nitrogen, which is 14. H is water, which is 1. So 1 times 3 is 3, plus 14 is 17. So we have 17 grams of NH3 per 1 mole of NH3. Actually, let's draw this a little closer. So right here, we have our given. Then we have our molar mass converting. This just takes our grams. This converts it to moles. Now we have to do our mole ratio. But which one goes on top and which one goes on bottom? So we know they have to cancel out. So moles of NH3 has to go on the bottom. We look at, there are 4 moles of NH3 here. It's just taken from the balance equation. 4 moles of NH3. And here we see 6 moles. 6 moles of H2O. Now, this right here is our mole ratio. But now we have to convert back to grams. So we have 1 mole of H2O. And how many grams are there, though? Well, H2O, oxygen is 16, hydrogen is 1, 1 times 2 is 2, plus 16 is 18 grams of H2O. We cancel out our units, we cancel out moles of H2O, those cancel out. Moles of ammonia cancel out, and grams of ammonia cancel out. So we're left with this right here, and we know it's going to be equal to something in grams of H2O. So let's actually down and dirty and do our calculation. So let's see our calculator here. We have 21.2 times 6 times 18 over 17 grams of ammonia over 4 moles of ammonia is equivalent to about 33.7 grams of water. Okay, I'm Scholastic Sam. Thank you guys for watching this video on mole ratio and mass to mass conversions. If you have any questions, comments, or concerns, please leave them down in the comment section below. Please like, subscribe, and turn on post notifications. A big shout out to my chemistry teacher, Dr. B, for teaching me all this information. Please join us next time where we talk about yields. Thank you guys, goodbye, and always remember, knowledge is power.